Welcome to Theory of Computation. Today I am going to give an introduction about primitive recursive functions. So it comes under an undecidable problems category. Recursive functions are generated from a basic functions. Three basic functions using two operations are supported for primitive recursive functions. So what are the three basic operations means zero function, which is also called as constant function. So this zero function is also called as constant function. And another one is successor function. Then the third one is projection function. So these are all the three basic functions. Using this only recursive functions can be framed. So zero functions are always denoted as 0 of x. So for any value of x, if you consider x as an integer value, for any value of x, the answer is 0. Successor means s. So s of x equal to its immediate value, x plus 1. Projection function is for list of values. From a list of values, there are n number of values are available. I want to find the mth value from n. It is a projection. So your m value should be greater than or equal to 1 and n value should be greater than or equal to m. So this is the conditions for three basic functions. So applying these three basic functions, we can able to frame recursive operations. So here the question is asked like this: apply primitive functions for calculating h of x. So they are giving three different functions with two variables g1 xy, g2 xy, g3 xy. But the values are differed. For g1 the answer is x plus y, for g2 it is 12x, for g3 it is 3xy. And I want to frame xyz. So there are three values. You should sum up these three values. So from this what we should understand means we should use three functions g1, g2, g3 instead of this x, y, z. And here x means the g1 of xy value, y means g2 of xy value, z means we should substitute g3 of xy value with some property. So h of x equal to some function. In this function, three variables should be used. Those three variables should be summed. So g1 of xy plus g2 of xy plus g3 of xy. You substitute those values. So here common x value is available. X plus 12x means 13x. Only one common variable plus xy value is 3xy plus y. So this is the answer. The same thing for the next one. f1, f2, f3. There is no input parameters. They are directly given as f1. So f1 is equal to x1 squared, x2 squared. f2 is equal to gamma. f3 is equal to 5x1, x2. So g of x1, x2, x3. So you should use f1 instead of x1, f2 instead of x2, f3 instead of x3. And I want to multiply that f2 value and f3 value with 5. That is the logic. Okay. So you write 5, then your f2 value, f3 value, f2 value is gamma, f3 value is 5x1, x2. So these are all the multiplications. So constant values are 5 and 5, 5 5s are 25, gamma is a variable, x1 is a variable, x2 is a variable. So the final answer is 25 gamma x1, x2. Like this, we can able to write primitive functions. So these are all primitive functions. Primitive recursive means a set which contains three basic functions. What are the three basic functions? Zero, successor, projection. And those functions should closed under composition, and primitive recursion means those functions are called as primitive recursive functions. So we can able to use addition and multiplication properties for these things. For addition, so here addition means sum of x comma 0. If you sum x with 0, the answer is x. If you sum x with y plus 1 means it will be recursively write it as sum of x comma y plus 1. So I want to find a solution for sum of 3 comma 5. So if you substitute directly means 3 plus 5 means 8. So how this 8 will occur by using primitive recursive function? We want to prove it. So you take the example. So this is the main concept. So instead of x, 3 is available. Instead of y plus 1, 5 is available. And the final answer should be sum of x comma y plus 1. So sum of 3 comma your y value is 4. Because y plus 1 is 5. So y value is 4 plus 1. Again, we should substitute it as sum of x comma y plus 1. So it is 3 plus 1 is y plus 1 value. So it will be rewritten as sum of 3 comma 3 plus 1. Plus already 1 is available. Then we should again use recursive operation. So sum of x comma y plus 1. Here y is 2. So if you substitute the answer, it is sum of 3 comma 2 plus 1. The remaining 2 pluses are there. So it will be repeated up to sum of 3 comma 0. Once sum of 3 comma 0 occurred, the answer is x. So it is 3. The remaining 5 ones are added with 3. So the answer is 8. So in this way only addition operation can be done. For the multiplication operation, if you multiply 0 with any number, the answer is 0. But if you multiply x with y plus 1, the answer is multiplication of x comma y plus x. So instead of multiplication, you can use repeated addition. So that is the answer. So multiplication of 3 comma 2 means 3 into 2, 6. So how this 6 occurred? I apply the same formula of recursive. So multiplication of 3x comma y plus 1 plus x. So here it should be written as multiplication of 3 comma 0 plus x, 3 value. Multiplication of 3 comma 0 is 0. The remaining values are 3 plus 3 is 6. So 0 plus 6, 6. In this way, the multiplication operation can be done using primitive recursive function. And the same thing for factorial. Factorial of 0 is 1. Factorial of x plus 1 is equal to factorial of x into x. So if any multiplication is available, you can use multiplication operation. So what is your multiplication operation? Multiplication of x comma 0 is 0. Multiplication of x comma y plus 1 is equal to multiplication of x comma y into x. So if any number is like that, you can write the same notations. So this is the answer. Factorial of 3, it will be rewritten as multiplication of 2 comma 3. So you apply the formula and you try to find a solution. The same thing for power. Power of x comma 0 is successor of 0. Successor means the next immediate value. So it is 1. Power of x comma y plus 1 is power of x comma y into x. It is also like a factorial concept. Predecessor means previous value. The previous value of 0 is also 0. Previous value of x plus 1 is only x. And we can also use approximate difference. So x approximate difference with the 0 is the same x. X approximate difference with y plus 1 is predecessor of x mod y. We can only find the predecessor value if and only if x is greater than y. In this situation only we can able to solve this notation. So for all these problems, recursive operations are available. So using this concept, we can implement a primitive recursive function formula. Thank you.